All right, here we go. What do I need to do with this 2x here? Distribute. What does distribute mean? Multiply. Multiply. Very good. So we are here multiplying. What do we get when I multiply? 2 times x to the third. Yeah? How did the 3 get there? Yeah, 1 and 2 makes 3, right? So you get to add those x. Okay, good. And when you distribute the 2x to the 5xy, what does that give you? 10x squared y. Okay, good. So now, today, we are starting here. And I'm asking you, hey, when you look, I see 1, 2 terms. What do they have in common? They both have just one x? X squared in common, right? What else do they have in common? A number, yeah, what number? 2. Ladies and gentlemen, this is why you learned what a greatest common factor was. Today we are factoring out the greatest common factor that says when you look at 2 terms, what do they have in common? So when I look, I see a 2, I see a 10. They both have a factor of 2. Here we have x cubed, here we have an x squared, which means they both have an x squared in them, right? Okay. And so we want to be able to recognize that greatest common factor and undistribute it. So we're going backwards and we're pulling out that greatest common factor, undistributing. That was kind of a bad example, it turns out. All right, over here, again, I'm going to multiply. 3x times 3x is 9x squared. And then 3x times 2. And I also need to distribute or FOIL my negative 2 in. So negative 2 times 3x, negative 6x. And negative 2 times positive 2, negative 4. What happens with those terms? Yeah. The middle term goes away, and we're left with 9x squared minus 4. It's true, they don't have a DCF. But you'll notice, first of all, there are 2 terms. This has a very specific name. It's called difference of squares. Difference of squares. What do you suppose difference refers to? The subtraction. And then difference of squares refers to their perfect squares, meaning this is 3x times 3x, or 3x quantity squared, which gives you 9x squared. And 4 is a perfect square. 2 times 2, or 2 squared. And so this has a very special name. It's difference of squares, and I'm going to use that phrase a lot. Difference of squares is what we call a special pattern. And when you see difference of squares just like this, it double bubbles really easy. You see that pattern? It's a pattern, right? 3x and 3x. Negative 2, positive 2. Easy pattern. All right. So that's what we're looking at today. Some special patterns and greatest common factor. So example 1, factor the expression. Look for the GCF. Look for the GCF. First, whenever we're factoring, we're trying to figure out what times what equals what we've been given. So sort of taking 2 things apart. So I have 3x squared plus 12x. So what is their greatest common factor? 3. So both of these terms are divisible by 3, and they both have an x. So that GCF is 3x. So what I do is I undistribute it. I'm taking a 3x and dividing it out as opposed to multiplying it in. We're doing it in reverse. So when I take out a 3x from here, what's left behind? X. All right? When I take out a 3x from 12x, what's left behind? A 4. How do you know if you did it right? Just distribute. Okay, so 3x times x is 3x squared. 3x times 4 is 12x. This is it. This is factor. You did it. All right, looking at letter B, 6x squared y cubed plus 27xy to the 4th. GCF, greatest common factor. What number do they have in common? 3. 6 times, or 2 times 3 is 6. 3 times 9 is 27. So they have a 3 in common. What about x's? Do they have x's in common?
Yeah, just one.
Just what, x to the 1st? And then y cubed. Very good. How does that work with the powers? How do you know, like, how come I couldn't take out the x squared?
Only has one.
Yeah, this one only has 1. This has x and times x, so there's more to choose from. We always go with the lowest power. Okay? The lowest power of the variable is how you figure that. Now, if I take out that 3, x to the 1st, y cubed, I want to know what's left behind. So if I take out a 3, what's left in that first term? A 2. I take out an x, what's left behind? An x. If I take out a y cubed, what's left? A 1. Yeah, a 1. All right. What about the second term? If I take out a 3, what's left behind? 9.
Oh yeah,
9. If I take out an x, it's gone.
Yeah.
And what's left for y? Just a y. How do you know you did it right? Distribute. That GCF is overlooked. So I hope you guys get really good at GCF. Okay? All right. Here, slightly bigger numbers. What is the GCF when you look at all 3 terms? What number? 6. X to the 3rd. They each have at least an x to the 3rd. So I can take out that 6x cubed. And really what we're doing is dividing. We're unmultiplying. So if you're unsure, I like to write it out. And I literally just divide each term by that GCF. And clean up the fraction. What's left behind? 5. What's left behind here?
7x.
7, a positive 7x. And what's left behind here? Negative 4x squared. So again, we are unmultiplying, which happens to be the same as dividing. Okay? So if you're ever confused, you can always just divide that term out, and I think it's really easy to clean it up then. All right. Do you have any questions for me on that? Okay? All right. Oh my God.
Oh my god.
More, yes, but wait, there's more.
Like letters of the H at this point?
No, I don't know my letters of H. I'm just saying. Like who's like what comes after J? I don't know.
Oh, me? That was a bad mistake.
What's after?
All right. All of these are special patterns, but we always, rule number one of factoring is always look for a GCF. So on each one of these, you want to be sure, is there a GCF? Do they have anything in common in these two terms? No. Which means if there's no GCF, then I'm going to try to double bubble. Just like we did this weekend, we're going to try to factor unfoil. So we ask ourselves, what times what is x squared? X times x. And then last times last has to be negative 49. What times what is negative 49?
7 and negative 7.
Positive 7 and negative 7. How do you know you did it right? Check the rainbow. Check the rainbow. We have a negative 7x and a positive 7x. And what does that make? 0. Is it sufficient to say x squared plus 0x minus 49 is equivalent? Okay. So this is a special pattern. It's difference of squares. Perfect square minus a perfect square, and it's always going to factor in this manner. The nice thing is, just like we did on Friday, first times first has to be the first thing. Last times last has to be the last thing. The middle term cancels out. So let's try another one. Letter E. Is there a GCF? No GCF. But what do you notice about it? Difference of squares. First times first has to be 16x to the fourth. What times what is 16x to the fourth? 4x squared times 4x squared, right? Is that the only option? No, but it's a really good one. And then last times last has to be negative 81y to the fourth. What times what is negative 81y to the fourth? Positive 9y to the, and negative 9y to the second. How do you know you did it right? Check the rainbow. Multiply it back out, it'll work every time. Okay. Letter F. Is there a GCF? Yes, there is a GCF. What is the GCF? 3y. Yeah? Okay, so the first thing we need to do is undistribute that 3y. If I take out a 3y from my 48y cubed, what's left behind? 16y squared. Very good. And if I take out the 3y from that second term, what's left behind? Negative 9. Now we can factor even more, because right here inside my bubble here, that is difference of squares again. And that's going to double bubble. So sometimes you have to do multiple factoring methods. GCF is always first, greatest common factor first, and then check to see if you can double bubble again. So first times first has to be 16y squared. What times what is 16y squared? 4y times 4y. And then last times last has to be negative 9. What times what is negative 9? Positive 3 and negative 3. And that is fully factored. Is that out of focus or is it me? All right. Okay, Okay, G and H, same thing here. We're going to do the same thing. Is there a greatest common factor on letter G? 1. Hey, very good. 1. There's always a GCF. It might be 1. 1 doesn't help us too much. So, but yes. So it is a trinomial. Try to factor. Trinomial, try to factor, or try to double bubble. Same process, ladies and gentlemen. First times first has to be the first thing. What times what's x squared? X times x. And then last times last has to be the last thing. What times what is positive 25? What else? Negative 5 times negative 5. And what do we want? Positive 5 and positive 5. How do you know you did it right? Check the rainbow. And when you check the rainbow, does the middle term cancel out? No. 5x and 5x gives me that 10x. Is there another way I could write this? X plus 5 quantity squared. Either way works for me. I prefer this way, actually. This one. All right. Letter H. What do we check first? Greatest common factor. Good. 2y. 2y is the GCF, so I'm going to undistribute that 2y. Divide it out. Divide it out. What's left behind in the first term? 4x squared. Good. Now in the middle term, take out that 2y. What's left? Negative 12x. And then what's left in the third term? Plus 9. How do you know you did it right? Distribute, yeah. All right, now I have a trinomial. What should we try to do? Double bubble. Try to double bubble. Try to factor. Trinomial, try to factor. All right, so first times first has to be 4x squared. What times what's 4x squared? 2x times 2x. Is that the only option? I could have used 4x times 1x, right? Okay. But it's a perfect square, so I usually will choose that. And then last times last has to be positive 9. What times what is positive 9? Negative 3 and negative 3. Or positive 3 and positive 3. What do you want to try? Negative 3 and negative 3. How do you know if you did it right?
Rainbow.
Rainbow. Check the rainbow. 2x times negative 3 is negative 6x. And then negative 3 times 2x. And that makes our negative 12 our middle term. So we did it perfectly. Factoring is just multiplying in reverse or dividing. Okay? Same thing. Do you have questions for me? Sorry.